All right, for qualitative analysis, we'll be identifying a set of gases or set of ions. To identify these ions, we have to bring them out from the salt. Now, I want you to know one thing, that every compound in chemistry has two parts: the anions and the cations. So you'll be asked to differentiate them. After your knowledge in qualitative analysis, you should be able to identify any compound that you are given. That's the cations and then the anions. So let's take some cations. Zn2 plus, you can take CO3 2 minus, Fe2 plus, SO3 2 minus, Fe3 plus, SO4 2 minus, Ag NO3 minus. You have NaH4 plus, you have Cl minus. Then you have Pb2 plus, you have Cu2 plus, then leave out OH minus. I'm bringing out only those ions that you identify.
I minus.
That
I minus.
the ones that will come up that these ones are okay. So these are a set of ions. So you can add anything here, maybe Br minus. Okay? Maybe Br minus. Then for copper, you can take in S2 minus. So we have this set of ions that we will be required to identify. Okay? We have this set of ions that we will be required to identify. Now the first thing you do is, all these anions, they release gases when they are heated. When they are heated strongly, they release gases. And you must be able to identify their gases. Some of them are colorless, odorless, and some of them have confirmatory tests. So let me start with this first one, carbon 4 oxide. Carbon 4 oxide is colorless, odorless, and then turns lime water milky. Carbon 4 oxide, I say when you heat these salts, they release gases. Then when you are able to identify the gas, then you will know the salt that they are coming from. So if you heat a substance and a gas is evolved, the gas is colorless, odorless, you should know that it is, and then turns lime water, wet blue litmus paper red. Because for gases, you have to check their color, their odor, their action on litmus. Those are the first three tests you carry out. So with the first set I have here are hydrogen, oxygen, water vapor. All of them are colorless, odorless, and have no action on litmus. But when you come down to carbon 4 oxide, it is colorless, odorless, but has action on litmus. It turns blue litmus paper red. And then all these other gases too turn blue litmus paper red. But then that's where the confirmatory test comes in. For carbon 4 oxide, you will not test it with lime water. If it turns lime water milky, then you are sure that the gas is carbon 4 oxide. And carbon 4 oxide can only come out from a trioxocarbonate 4 or a hydrogen trioxocarbonate 4. These are the two things that can liberate carbon 4 oxide gas. Now, if you heat the substance and the gas that comes out is colorless but not odorless, it has an irritating smell, maybe with match, then you know that is not carbon 4 oxide. Then you start looking at sulfur 4 oxide. So what is the confirmatory test? You will pass it through, or you take a glass rod, dip it in potassium permanganate. Okay, that's potassium tetraoxomanganate 7. It is purple. If it decolorizes it, then that's your confirmation that it is sulfur 4 oxide. Okay, that's your confirmation that it is sulfur 4 oxide. Okay, if it is hydrogen sulfide too, it will decolorize KMNO4, but hydrogen sulfide will smell like rotten egg. Then if you heat and you see a reddish brown gas, which will now turn lead iodide paper blue black, you will now say that gas is NO2. from NO3 to minus. We also have NO2. Okay? SO4 and SO3 will release SO2 gas. NO3 and NO2 will release NO2 gas. NO3, NO2 will release NO2 gas.
No, it's confusing.
NO3, NO2 release.
We have NO2 too now. We have gas. Don't you have potassium dioxynitrate 3? You have dioxynitrate 3 salts now. You have trioxynitrate 3 salts. But both they will release nitrogen 4